4.5 focuses on graphing rational functions. So let's look at the function f of x equals x minus 4 over x plus 2. The first thing we want to do is identify some key characteristics of this graph. So the numerator and denominator are not factorable. So we're going to look at the numerator for our roots. So the numerator is x minus 4. And when you set that equal, you get x equals 4. So that tells me that we have an x-intercept at 4, 0. Our denominator is x plus 2. And when you set that equal to 0, you get your vertical asymptote. So that's x equals negative 2. So let me go ahead and plot my x-intercept, which is at 4. And then I'm also going to draw in my vertical asymptote at x equals negative 2. So this is a wall I like to think of. The graph is going to approach it, but it will never cross it or touch it. The next key characteristic we want to look at is our horizontal asymptote. And because this is balanced, meaning that the exponent on the top, which is 1, is equal to the exponent on the bottom, to find our horizontal asymptote, we just divide our leading coefficient. So the horizontal asymptote is going to equal 1 divided by 1, or y equals 1. So let me draw that in also. Okay, so now we have that. And the last thing I like to look for is my y-intercept. So the definition of y-intercept is the y value when x equals 0. So to find that, I'm going to take, so f of x is going to equal 0 minus 4 divided by 0 plus 2, which is going to be negative 2. So I have a y-intercept at 0, negative 2. So when we look at this, on the right side of the asymptote, we have enough to sketch our graph. Because of the asymptotes, we can kind of figure out what's going to happen on the right. So now let's see what's going to happen on the left. So what I recommend you do is pick a couple numbers that fall on the left side of your vertical asymptote. So for example, maybe x equals negative 3 and x equals negative 5. Substitute those values in to get your points. So after making my t-chart, I can see that at the point negative 3, I have a y value of positive 7. And at the point negative 5, y is 3. So again, I can kind of see what's going to happen. I'm going to connect these points, making sure I stay to the left of the vertical asymptote, but above the horizontal asymptote. So my domain for this function would be, let's put that at the top. So the domain of this function would be negative infinity until you get to your vertical asymptote of negative 2, union negative 2 to infinity, and the range would be going from the bottom of the graph, negative infinity, until you get to your horizontal asymptote, which is positive 1, union 1 to infinity. So now let's move on to example 2. This one is not in quotient form because of this minus 2. So we're going to do this one just a little bit differently. We're still going to look at our denominator for our vertical asymptote. So when I set the x minus 3 equal to 0, I get x equals 3. So let's draw in that vertical line. And this is my vertical asymptote. Now we're going to look for our horizontal asymptote. Our horizontal asymptote, because this is balanced, we're still going to take our leading coefficients, and divide them. But because of that -2, we have to subtract it. So we have a horizontal asymptote at y equals 1 minus 2, which is y equals -1. So now let's find our roots, or our x-intercepts. The definition of x-intercept is the x value when y is 0. So I'm going to set this up as an equation. X equals 0 equals x over x minus 3 and subtract 2. And let's solve this for x. First I'm going to add the 2. And then I'm going to cross multiply, treat this like a proportion. So that gives me x times x equals 2 times x minus 3. Subtract 2x. And we get x equals 6. So we have an x-intercept at 6, 0. And now let's look for our y-intercept. So again, the definition of y-intercept is the y value when x equals 0. So when I substitute in a 0 for x, I have 0 divided by 0 minus 3 minus 2. And that is going to give us y equals -2. So we have a y-intercept at 0, -2. And this is our y-intercept. Okay, so we don't have quite enough to make our graph. So at this time, I am going to plot in some more points so I can get a clearer picture of what's happening in this function. You can choose any points. I am going to choose +2 and +4. So I substituted in +2 and I got a y value of -4. And then I substituted in a +4 and I got y equals 2. We're going to look at our horizontal asymptote for our range and our vertical asymptote for our domain restriction. So let's start with our domain. Our domain would be -infinity until I get to my vertical asymptote, which occurs at +3, union 3 to infinity. And my range is starting from -infinity until I get to my horizontal asymptote, which occurs at -1, union -1 to infinity.